for now. I could provide a more explanatory message, but for now I'm going to keep things simple and just exit the program prematurely so that I can trust hereafter that sys.argv has what I want. And now I have the opportunity to use the requests library to write some Python code that effectively is pretending to be a web browser so as to connect to that same HTTPS URL on Apple's own server. So now that I've guaranteed that the user has typed in not just the name of the file, but also the name of a band at the prompt, giving me a length of 2 for sys.argv, let's go ahead and execute requests.get, which is a function inside of the requests package that will literally get some response from a server. And the URL that I want to get is exactly the same as before, https://itunes.apple.com/search, entity equals song, ampersand, limit equals 1, ampersand, term equals previously Weezer. But let's make this program a little interactive and actually allow the human to specify at the command line what artist they'd like to search for. So I'm going to go ahead and close my quote early and just append, using the concatenation operator as in the past, sys.argv bracket 1. And now it'd actually be nice to store the response from the server in a variable. So I'm going to go ahead and say response equals, and to store all of the response that comes back from the server in a variable called response. Down here now, I'd like to just understand what the server's returning to me to make sure I know how next to proceed. So this isn't going to be very pretty yet, but I'm going to go ahead and print out response.json, which ensures that the data I'm getting back is formatted on my screen as exactly that, JSON, the same text format as we saw on my screen. It's not a useful program yet. I'm really just learning along the way. But let me go ahead now and increase the size of my terminal window and run Python of itunes.py and type in the name of a band like Weezer and hit enter. And what we see on the screen, formatted almost the same as before, is exactly that same text. But what you'll see here is that this has been standardized now as a Python dictionary. What indeed Apple's returning is technically a JSON response, JavaScript object notation. But Python, the requests library, is converting it to a Python dictionary, which happens to use, wonderfully coincidentally, almost the same syntax. It uses curly braces to represent the dictionary here, and a closed curly brace to represent the end of it here. For any lists therein, it uses a square bracket here and a closed square bracket down here. It uses quotes, single quotes in this case, or equivalently double quotes to represent the keys in that dictionary. And after a colon, it stores the value of that key. And so you'll see that indeed we have a result count key whose value is 1, but then a more interesting result key called results, whose value is this entire list of data. Now, honestly, this is such a big blob of text that it's going to take me forever to wrap my mind around what I'm seeing. So let me propose temporarily we use another library in Python that will allow me to format my data a little more cleanly. It turns out that Python also comes with a special library called JSON that allows you to manipulate JSON data and even just print it. That is, format it in a way that's going to be way easier for you and I to understand. So let me go back to my code here. Let me shrink my terminal window. And let me propose that just temporarily, again, we do this. Let me import this additional library, JSON, which comes with Python. So I don't need to install it manually with pip. And let me go ahead now and not just print out response.json, which was that big blob of hard to understand text. Let me go ahead and use one other function here called json.dumps for dump string, and pass to that function that response.json return value. So again, I'm just introducing another function who I claim it has a purpose in life of pretty printing, nicely formatting on the screen the exact same information. And I know this from the documentation, having done this before. But I'd like things to be nicely indented. And according to the documentation, if I pass in a named parameter of indent equals 2, that's going to indent everything at least 2 spaces. I could do 4 or something else, but it's going to be enough to help me wrap my mind around what the data is I'm getting back. Because again, I'm just learning along with you. So let me increase the size of my terminal window again. Let me run Python of itunes.py. And again, let's search for Weezer and hit enter. And now notice it's still a little bit cryptic because there's a lot going on here. But my gosh, I can totally read this more easily now. Notice now that I still see the first curly brace, which means, hey, This is a dictionary in Python, a collection of keys and values. The first key is called result count. It happens to be displayed in double quotes now, but that's just an issue of formatting. It could be double or single so long as we're consistent. The value of that key is 1. Why? Well, I told the URL to only limit the responses to one Weezer song, so I've gotten a result set of 1. If I increase that limit, I could probably get more. Then the interesting part of this response is really the data itself. Notice in the results key here, there's a really big value. The value is a Python list, as implied by this square bracket. What does this list contain? Well, I know from skimming it earlier that this contains one dictionary. And that's why we see another curly brace here. So again, if this gets a little more complicated, keep in mind that a dictionary is just a collection of key value pairs, and Python uses curly braces to indicate as much. It is perfectly reasonable for a dictionary to be inside of another dictionary if the value of some key itself is another dictionary. So this is a common paradigm, and even though it might seem a bit cryptic, it's just something that allows us to associate more keys with more values. Now, most of this information I probably don't care about. For instance, according to Apple, the unique identifier for Weezer is apparently 115,234. That might be useful if I'm making my own database and I want this to be searchable, but for today's purposes, all I care about is the name of the track, otherwise called track name as key. And the first song, and only song, because we limited it to one, that we got back from iTunes here is the song that you might know by Weezer called Say It Ain't So. So now I have a bit of a clue. If my goal here is to implement a program called itunes.py that doesn't just dump the response from the server, which is admittedly very cryptic, but to print out all of the songs that iTunes has for the band called Weezer, maybe I can iterate over this somehow. So let me backtrack. Here's the key called track name. It is inside of a dictionary that is the value of results here. So how can I go about getting this? Well, let me go ahead and try this. Let me go ahead and shrink my terminal window back down. And let me propose now for one final flourish, we don't just lazily print out the contents of that response, because that's not interesting or pretty for anyone. Let's do this. Let me go ahead and create a new variable, just for the sake of discussion, called O for object. And I'm going to go ahead and call O equals response.json, just to store that JSON response specifically in a variable called O, but I could name it anything I want. And now I'm going to do this. For each result in that object's key called results, go ahead and print out that result's track name. And notice I have used exactly the same capitalization. Track name has a capital N. Results is all lowercase. And let me rewind before we run the actual program. In line 8, we are making an HTTP request using Python to the server, just like you and I as humans type URLs into a browser and hit enter. This is the Python equivalent thereof. I am then on line 10 just grabbing from that variable that contains the server's response the JSON object that I care about, the thing between those curly braces at the very top and the bottom. But because we've poked around and because I read the documentation earlier, I know that that object has a key called results. And that results key, again, is a list. Now, at the moment, that list contains only one song, Say It Ain't So, because I limited my response to one. But even so, my loop will work. It's just going to iterate once. And each time through that loop, it's going to print the current results track name. If I want to make this even more interesting, let me change this limit now from 1 to 50, so I'll at least get back 50 track names instead. Let me go ahead now and increase the size of my terminal once more and go ahead now and run Python of itunes.py, searching again for a band like Weezer. And here we go. And voila, there are 50 songs that iTunes has for Weezer. And if we scroll back up to the top here, we'll see that the very first one there is indeed Say It Ain't So, but now we got Undone, the Sweater Song, Buddy Holly, apparently another rendition of Say It Ain't So, perhaps from another album, another Buddy Holly, Undone, My Name is Jonas, and so forth. Questions now on this program, which integrates Python with a real-world third-party API.
Yeah, hi. Can we use break instead of system.exit?
Good question, but no. Break, again, is used to break out of things like loops, like we saw earlier. Sys.exit is used to break out of the whole program itself. Use break for loops for now, and use sys.exit to terminate the whole program. Good question. Other questions now on this program or others?
From where we bring the name of the key results?
From where do we get the name of the key?
Results itself. يعني, can we change the results name?
You cannot. So we could in our program. So the keys that come back in that JSON response, to be clear, come from itunes.apple.com. Some engineer, some team of engineers decided for us what all of those keys would be called, including track name, results, result count, and everything else. You and I can absolutely store those same values in variables, just like I'm doing here with O, just like I'm doing here with result. You can rename those keys anything you want using Python variables, but the JSON response is coming from that third-party server. Other questions?
Yes, sir. So I have a question related to Cowsay package. So like, yes. So sir, what sort of ASCII graphics is it capable of outputting?
The Cowsay package. I would refer you to the URL in the slides earlier, if only because it's more thorough. They have not just cows, but Tyrannosaurus rexes and several other animals as well. I should emphasize that this is not a package I suspect you will use much in the real world. It's really just meant to be representative of the types of packages you can install. But allow me to refer to the documentation for what more is there. But ASCII art is all we had before there were emojis, let alone GIFs and JPEGs and pings. But it's what is immortalized in Cowsay. Well, allow me to transition us back now to one final capability of Python, which is that you yourselves have the ability to make your own libraries. Up until now, we've been writing all of our functions in our one file, hello Py and everything since. And now that we've introduced modules in Python, like random and statistics, we can import those that come with Python, but that's other people's code as well. And we've now used pip, this package manager, to install third-party packages as well in the system, and using other people's code still. But to come full circle, what if you yourself find yourself implementing the same kinds of functions again and again? Or you find yourself opening up old programs, copying and pasting code you wrote into new programs because you have the same problem yet again. A good practice would be to somehow bundle up that code you keep reusing and make your own Python module or package. You can keep it local on your own Mac or PC or cloud server, or you can go through the steps of actually bundling it up, making it free and open source, and putting it on something like PyPI for others to use as well. OK, I'm going to go ahead and run code of sayings.py to create a brand new file called sayings.py, which is going to be my own sayings module. And I'm going to define a couple of simple functions in there. I'm going to define a hello function that's going to take a name parameter as input. And that function is simply going to print out an f string that contains hello, comma, and then in curly braces, whatever that person's name actually is. Then I'm going to go ahead and define one other function, a goodbye function, that has def goodbye, also takes a name as its input, and then that prints out by contrast an f string that says goodbye, comma, and then in curly braces, name. And now, just for good measure, just so I can be sure that these functions are working as expected, I'm going to go ahead and define a main function in here too, just for the purposes of testing. And I'm going to go ahead and define a main function that simply does a couple of tests. For instance, it calls hello of quote unquote worlds, shall we say. And then it's going to call goodbye of quote unquote world as well. And hopefully what I'll see on the screen then is hello world and goodbye world when I run this program. Of course, as always, I need to explicitly tell Python to call that function. So I'm going to call main at the very bottom of this file. All right, let's try it out. Python of sayings.py, enter. And indeed, I see hello world and goodbye world. And so I think it's reasonable for me to assume that these functions, albeit simple, are pretty correct at this point. But now suppose that I want to use these functions as though I've indeed created my own library, my own Python module that makes available a hello function for me or anyone else who wants to use it, or a goodbye function as well. Well, let me go ahead and open up, again, say.py, but start fresh. And rather than have the cow say anything, let me go ahead and have my own library do the talking. So I'm going to go ahead and, as before, import sys so that I have access to command line arguments. And from my own module called sayings, I'm going to import hello. So because I created a file called sayings.py, I can say from sayings, and it's inferred by Python that I mean sayings.py, at least in this current directory. But I specifically am going to import just one of the functions for now, namely hello. And now I can do something like this. If the user obliges by giving me 2 command line arguments, which I can check by just checking the length of sys.argv, I'm going to then go ahead and call this new hello function, passing as its input sys.argv bracket 1, which should hopefully be the person's name, which I'm going to expect them to type at the prompt. So here we go. I'm going to go down to my terminal window, run python of say.py, and my own name, because I want my own name to end up in the command line arguments and therefore be part of the hello. So when I hit enter in just a moment, I should hopefully see hello, comma, David. So here we go. Enter. And I see hello world, goodbye world, and then I see hello David. So why is this happening? Well, it turns out, even though I've done everything according to our own past practice, it's not really the right way to go about calling main after all. If I'm blindly calling main here at the bottom of my file, that means whenever this file is loaded by Python, main is going to get called. And unfortunately, that's true even if I'm importing this file or just a function from this file, as I am here in my say.py program. This is to say on line 3 here, when I say from sayings import hello, this effectively tells Python to go find that module, sayings.py, read it from top to bottom, left to right, and then import specifically the hello function. Unfortunately, by the time Python has read the file from top to bottom, left to right, that last line of code recall is to call main. Main gets called no matter what. So really, the right way to go about using a main function, which does solve that problem of ensuring that we can order our functions however we want, and all the functions will be defined at the time they're invoked, I shouldn't be unconditionally calling main at the bottom of this or really any of my programs. I should instead use this technique. I should say if underscore underscore name underscore underscore equals equals quote unquote underscore underscore main underscore underscore close quote, then and only then should you actually call main. Well, it turns out that this variable is a special symbol in Python, underscore underscore name underscore underscore. And notice that VS Code, because of its font, isn't quite showing those 2 underscores, but they're indeed there to the left and the right. This is a special variable whose value is automatically set by Python to be quote unquote main when you run a file from the command line, as by running python of sayings.py. So watch what happens now with this additional conditional in sayings.py. If I run python of sayings.py, it still works as before, because name will be automatically set to underscore underscore main underscore underscore when I run this file using python of sayings.py. But notice this. Name is not going to be set to quote unquote main. It's going to be set to something else, technically the name of the module, when I instead import the file like I do here. So this highlighted line of code, even though it will cause Python to go find sayings.py, read it from top to bottom, left to right, it's going to ignore the call to main this time because it's wrapped in that conditional. In this case, when I'm importing a file and not running it directly at the command line, main will not get called by definition of that name's value. So let me go ahead and try this. Instead of running python of sayings.py, which is the module which contains that conditional main, let me go ahead here and run python of say.py, which is the program here before me that imports hello from sayings. But because of that conditional, it's not going to say hello to anyone else except me in this case. All right, we're here at the end of our week. It's only appropriate, I think, to import something other than hello. Why don't I go ahead and import not hello, but goodbye from here? Let me go ahead and call goodbye instead of hello. And this time when I run python of say.py, I'm not going to type my own name. Allow me, if I may, to type in the whole world so that our final sentiment today is goodbye world. Indeed, that's it for this week. We will see you next time. All right, this is CS50's Introduction to Programming with Python. My name is David Malan, and this is our week on unit tests. Up until now, we've been writing a lot of code, and you might have been testing your code by running your program and passing in some sample inputs, and running it again and passing in some sample inputs. Or you might have been waiting for us to test your code instead. But it's actually much better practice to get into the habit sooner rather than later of testing your own code using code of your own. In fact, whether you're writing a personal project or working in industry, it's very common nowadays to not only write code to solve the problems that you want to solve, but also to write a little extra code to test the code that you wrote. And that's what we're going to focus on today, writing our own tests so as to be all the more confident, all the more certain that the problems we have been trying to solve are in fact solved correctly. So let's rewind a few weeks now to a program we wrote a while back, namely to calculate numbers. And specifically, we left off with this calculator on trying to compute the power of a number, like x squared, or where x might be 2 or 3 or some other number as well. Well, let me go ahead and resurrect that file by going into my terminal window here and running again code of calculator.py. And let me go ahead and pick up where we left off way back when by defining a main function here. And then in my main function, I did something like this. I said x equals int of input, and I asked the user, what's x, question mark. And then I immediately went ahead and printed out something like x squared is, and then I passed in as a second argument to print the result of calling a function called square, passing in that value x. Now, of course, I haven't yet implemented the square function, so let's define that as well. Let me go down a couple of lines and define square. And it takes an argument, recall, a parameter that at the time I called n for number. So I'll do that again, though I could technically choose any name for this variable. And I recall did this. I returned n times n. And there were multiple ways to do this. The squaring a number is multiplying it by itself. So I could also use other syntax here, but this is what we ultimately settled on. And then recall that I ultimately called main in order to kick off the process of running this program. So just as a test manually, let me go ahead and run Python of calculator.py and hit enter. What's x? Let's start with 2. All right, x squared is 4. I think that's correct. So let's run it again just for good measure. Python of calculator.py. Let's type in 3 for x this time. X squared is 9. And I think that's correct. And I might be feeling pretty good at this point, and I go off and submit my code to a course, or I post it on the internet for others to use. But I haven't really methodically tested this code. And it's not necessarily the case that it works entirely. In fact, I haven't really considered a number of corner cases. I went with some pretty obvious numbers like 2 and 3. But what about 0? What about negative numbers? What about any number of other infinite numbers? Well, we're not going to test an infinite number of inputs to this because the program would never halt. But we should test some representative inputs ultimately. But before we do that, let's get into the habit of making sure that main isn't always called. Let's adopt this habit again of doing if underscore underscore name underscore underscore equals equals quote unquote underscore underscore main underscore underscore. Only then should we execute main. And I'm doing this now proactively because I want to make sure that when I import my square function, perhaps from another library, from another file, treating it as though it's a library, I want to make sure that main is not just automatically called itself. Now, what do I want to do from here? Now that I've modified this program as follows, well, let's go ahead and write a completely different program whose sole purpose in life is to now test this program. So I've got my actual calculator in calculator.py. I've readied myself to call main conditionally so that I can safely import one or more things from this file in another file. Well, what should that other file be? Well, by convention, I'm going to create a file that's called test underscore. And then because the thing I'm testing is the calculator itself, let's call this file testcalculator.py. That's going to give me a new tab in which I can write a brand new program whose purpose in life is now specifically to test that program, but really that program's specific functionality. Built into that program is the square function. Let's focus on testing that function. All right, so how do I access that function in this program? Well, recall that I can import a function from another file as though it's a library of my own, a so-called module. So I'm going to do this. From calculator, import square. I could go ahead and just import square itself, but then I would have to prefix my use of square, recall, by saying calculator dot everywhere. And it's just a little cleaner to just import the one function. And now let me go ahead and do this. Let me go ahead and define a function called test square. This, too, is a convention. If you want to test a function called square, your function for testing should be called test underscore square. Or alternatively, you could do square underscore test, but I'll adopt this convention here. Now, what kind of tests can we do? Well, I don't dislike the test I ran earlier, testing x equals 2 and x equals 3. But every time I want to test my program previously, I would have to do that manually. And that's going to get tedious. It's not going to be easy for someone else to test it. And if I'm actually working in the real world, it would be nice if I could automatically have my program tested again and again by having some automated process run my own code. So let's do that and take the human ultimately out of the equation. So how might I go about testing the square function that I've now imported per line 1? Well, in my test square function, why don't I do this? If the result of calling square of 2 does not equal 4, why don't we go ahead and print an error message? Because I know that in the real world, 2 squared should equal 4. So if square of 2 does not equal 4, there's a bug in my program. There's a bug in my function. I've made a mistake. So let me go ahead and print something like that so I or someone else knows 2 squared was not 4, for instance. So I could print out anything here. What should I maybe next test? Well, let's do more than one test. Let's say if the square of 3 does not equal 3 squared 9, then let's go ahead and print out that 3 squared was not 9. So I haven't done any more testing than I did earlier, but I've baked those two tests, x equals 2 and x equals 3, into my own code here. So I can now run those tests automatically, if you will. Now, it's not enough to just define a function called test square. I actually, if I want to run this function, need to call it somehow. And our convention for doing that is the same as always. In this function here, in this file too, let me define main. And main's sole purpose in life is going to be to test square. And now at the bottom of this file, as before, let me go ahead and adopt my convention of if underscore underscore name underscore underscore equals equals quote unquote underscore underscore main underscore underscore, then go ahead and call main. So a lot of this is just boilerplate. Like we've seen this before, defining a main function and calling a function to kick off some process. Now adding the conditional at the bottom of the file to make sure I'm only conditionally calling main just in case I import anything from this file elsewhere. So let's see. Let's go ahead and test my code now. Let me go ahead and run test calculator with Python and hit enter, and nothing outputs. Nothing outputs. But I think it's OK. I think no output is good because look at my test square function. I'm not printing anything if all seems well. So let's demonstrate as much by going back to my calculator and let me break it. Let me introduce a bug. Maybe I didn't even get it right the first time. Maybe my code originally looked like this. I wasn't thinking. I forgot my squares. And so I thought that the square of a number is n plus n instead of n times n. So a reasonable mistake to make, perhaps arithmetically. Let me now go back to my test calculator, which I'm not going to change, but I am going to rerun it. Python of testcalculator.py. I'm going to cross my fingers here, but for naught, I'm going to see immediately that 3 squared was not 9. Now, what is it? Well, let's see. When your tests fail, how can we put our finger on what's wrong? Well, it's a little interesting that I completely broke my square function, and yet only one of these tests is failing. It looks like this test, lines 9 and 10, is fine because I'm not seeing that output. But of course, these two lines, this test is failing because 3 squared is not 9 when I'm using plus. So just to be clear here, why is my function only partially broken? Just to be clear, why am I seeing only one error instead of 2, even though the square function is now mathematically broken?
Because 2 plus 2 is 4. No.
Yeah, I mean, it's as simple as that. I just got lucky that 2 plus 2 is the same thing as 2 times 2. So this is one of those corner cases. And this is why it's good to be in the habit of not just testing one thing, but test several and make sure you're covering your bases, so to speak. So I got lucky here, and that explains why I'm seeing only one error, even though the function itself is flawed. But let me propose that there's another way we could do this, because honestly, if I extrapolate from this simple example, running not just 2 tests, but 3 or 4 or 10 or 20 tests, you can imagine that, my God, the code is going to get so much more complicated than the function itself. I mean, already, look, in calculator.py, the function in question is 2 lines long. And yet in test calculator, the code in question is 5 lines long. Like, I've written more code to test my code than I actually wrote original code. So the fewer lines of code we can write when testing code, I think the more likely you and I are to do it, because it's going to be literally a little less work and just fewer opportunities for mistakes. So what's another approach I can take here? Well, it turns out in Python, there is another keyword that we haven't yet used, which is this here, assert. Assert is a keyword in Python and some other languages as well that allow you to do exactly that as in English, to assert that something is true, to sort of boldly claim that something is true. And if it is, nothing's going to happen. No errors are going to appear on the screen. But if you assert something in Python and it is not true, that is, the thing you're asserting, a Boolean expression, is false, you're actually going to see some kind of error on the screen. So let's go ahead and try this new keyword as follows. Let me go back to my code here. And just to make it a little simpler, let me propose that I use this new keyword as follows. Let me simply assert that the square of 2 should equal 4. So I've changed my logic. Instead of checking for not equals, I'm now asserting very loudly that it should equal 4. And then on one additional line, let me do the other test. Assert that the square of 3 equals 9. And that's it. No if, no indented print. I'm just going to assert more simply these two things that I want to be true. Well, let me go ahead now with calculator.py still broken. I'm still using plus accidentally instead of multiplication. Let me go ahead now and run Python of testcalculator.py. Crossing my fingers as always, but it's not going to go well this time. A whole lot of errors seem to appear on the screen. And if I scroll up here for this traceback, we'll see that the thing that failed was this line here. Assert square of 3 equals 9. Now, unfortunately, when you're using the assert keyword, it's not terribly user-friendly. It shows you the files and the line numbers involved, but it does show you the specific line of code that failed, the assertion that failed, so to speak. It's now kind of up to you and me to infer from this, well, wait a minute, why is the square of 3 not equal to 9? So it's not super user-friendly, but honestly, it was like half as much code for me to write. It's just 2 lines instead of those previous 4. But notice this. Little remnant down here, this was an assertion error. And we have seen errors before. We've seen errors before when we've made other mistakes in our code. And in the past, what was our solution for catching those errors? How do we catch errors that seem to resemble this, even though we've not seen this one before?
Try and accept.
Yeah, in Python, we can use the try and except keywords to try to do something optimistically, except if something goes wrong, do something else instead. So this is a step forward in that I can at least catch this error, but it's going to be perhaps a step backward in that I'm going to end up writing, I'll admit in advance, a little more code instead. So let me go ahead and try this. Let me go back into my code here, and instead of just asserting blindly, let me go ahead as Tolu proposed and try to do this first assertion, except if there is an assertion error, like we saw a moment ago, then go ahead and print out something more user-friendly that explains what actually failed. 2 squared was not 4. And let me go ahead similarly and try to assert that the square of 3 equals 9, except if there's an assertion error there, in which case I'm going to print out, more user-friendly, 3 squared was not 9. So I've taken a step forward, but also a step back because now I have more code, but I have at least introduced assertions and exceptions in a manner consistent with how we've seen in the past. When something goes wrong, you actually see an exception raised. Well, let me go ahead and run this version of the program now instead. Python of testcalculator.py, crossing my fingers. All right. It still failed because I'm seeing output, but we're back to at least user-friendly output. So that's at least progress in some way here. But it's, again, more code than might have been ideal. And in fact, if we continue this further, what if we actually want to add additional test cases here as well? Well, it seems like we might end up writing way more code than would be ideal. For instance, I'm testing 2 and 3 now. I should probably test some negative numbers as well. So why don't I go ahead and add in, for instance, let me go ahead and copy and paste this. Let me try to assert that the square of -2 equals 4, which should be the case mathematically. And if not, let me go ahead and change this to say -2 squared was not 4. And you know what? Let me go ahead and copy paste this again, test another negative number just for good measure. Let's test the square of -3, which should equal 9. But if it doesn't, let's go ahead and say that -3 squared was not 9. And just to think aloud here, what might be another good value to test? I've tried 2, I've tried 3, I've tried -2, I've tried -3. I can't try in infinite numbers, but there's at least something that's a little different in between those values. Let's try 0. 0 is an interesting case too, just in case something might be wrong. And why 0? I'm just going with instincts here, right? Odds are positive numbers are generally going to behave the same. Negative numbers might generally behave the same. 0 might be a little anomalous. There's no science to it necessarily, but rather considering for yourself based on your own experience, like what are the potential corner cases based on the function you're trying to test. I'm trying to test something mathematical, so I want to test representative values. So let me go ahead and paste in one more try except block. Let's assert that the square of 0 should equal 0. And if not, I'll say something explanatory like 0 squared was not 0. Now if I go ahead and run this, Python of testcalculator.py, and hit enter, now I see multiple errors. And this is interesting. It's a bit of a clue because notice that some, but not all of these assertions are failing. The one for 2 squared is apparently OK, as we noted earlier. Recall that 2 squared happens to be 2 plus 2, so that bug doesn't really throw off our test. But it's a good thing we tested for 3. It's a good thing we tested for -2 and -3 because all of those tests caught this error. The 0 test did not notice because 0 squared is, of course, 0, but 0 plus 0 is 0. So we're getting lucky or unlucky there, depending on how you view the glass as half full or half empty here. We, at least by way of having multiple tests, caught this mistake somehow. So it would be nice, though, if we weren't writing so much darn code here, right? Because notice what I've done. I have try, except. I have all of these assertions. I have a main function. I have this if conditional at the bottom of my file. I mean, honestly, who's going to want to write 31 lines of code now just to test a 2-line function, right? No one's going to write test code like this if we're all writing so much more code to do the actual testing. So people have solved this problem. If you are in the habit of testing your code a lot or wanting to, if I'm in the habit of wanting to test my code a lot, if everyone else in the real world is in this habit of wanting to test their code, why don't we create tools that make it a little easier to do so? And in fact, there is a mechanism for doing this whereby we can use a tool that's popularly called PyTest. So PyTest is a third-party program that you can download and install that will automate the testing of your code so long as you write the tests. But what's nice about this library and others like it is that it adopts some conventions so that you don't have to write as many lines of code yourself manually. They do some of that automatically for you. Now, this is a third-party library. There's other libraries for unit tests, so to speak, that is testing units of your code. Some of them come with Python itself. We're proposing that we look at PyTest today because it's actually a little simpler than the unit testing frameworks that come with Python itself. And what do we mean by unit testing? Unit testing is just a formal way of describing testing individual units of your program. What are those individual units? They're typically functions. So unit tests are typically tests for functions that you have written. Now, what does this mean in practice here? Well, let me go back to my VS Code here, and let me propose that we simplify my test calculator significantly. I'm going to go ahead and delete all of these tests, which were accumulating to like 31 lines of code. And let's see if we can distill the tests to their essence using PyTest. From my same calculator program, let me still import square. So I do still need that line of code so that I can test that specific function. Now I'm going to go ahead and define a function just like I did before as follows. I'm going to define a function called test square, again by convention, test underscore, and the name of the function you want to test, though it doesn't have to be that way. And now I'm going to go ahead and make a few assertions. I'm going to assert that the square of 2 should equal 4. I'm going to assert that the square of 3 should equal 9. I'm going to assert that the square of -2 should equal 4. And I'm going to insert that the square of -3 should equal 9. And lastly, for now, I'm going to assert that the square of 0 should equal 0. So I'm still using the assert keyword, as I introduced earlier. And even though it was a little tedious to type those, I mean, it's only 8 lines of code now, and they're so easy to type. It's not try and except and all of this. Wouldn't it be nice if something else, someone else, handled the try, the except, the printing, all of the standardization of actually running these tests? And that's where, indeed, PyTest comes into play. Per the documentation for PyTest, which can itself be installed with pip install PyTest, which we've used to install other libraries in the past, you can look at the documentation here for all of its formal usage. But fortunately, PyTest is pretty user-friendly as testing frameworks go, and it actually allows us to dive right in by just running PyTest on the code that we've written. So if I go back to VS Code here and look at my testcalculator.py, which notice has no main function anymore. It has no conditional. It has no tries. It has no excepts. It has no prints. It just has my few assertions. PyTest and other libraries like it are going to automate the process of running these tests for me and informing me on the screen whether or not any of those tests failed. So let me go ahead and do this. I'm going to go ahead and increase the size of my terminal window for a moment just so we can see more on the screen. And I'm going to run not Python as I've been doing. I'm going to run PyTest, which again is this third-party tool for running tests in your code. I'm going to run PyTest of test_calculator. So that same file, I'm going to cross my fingers as always and hit enter. And we'll see that, something has failed. Now, admittedly, even though I do think you'll find that PyTest is relatively simple to use, its output, at least at first glance, is not necessarily super user-friendly. So what are we seeing here? Well, notice at the very top of my window is the command that I ran after my prompt. Right below that is a single F in red, which means fail. So not very encouraging. I tried really hard here, but fail is my grade on this program. But let's see exactly what happened. Well, if I look at this excerpt here, under failures, you'll see that test square is the function that failed. All right, that makes sense because that's the only one I wrote. And you'll see here somewhat arcane output describing what the error was. So what you're seeing here is the first line of output, equals 4, which is fine. There's no red error message below that, so that one's OK. But this line of code here, assert that square of 3 equals 9, PyTest did not like that assertion because it didn't end up being true. In fact, per the red E at the start of this line, you'll see that I'm effectively trying to assert that 6 equals 9. Now, where did the 6 come from? OK, wait a minute. If my test involves this, notice that where 6 equals square of 3, this is saying that because I've called square, passing in a value of 3, it turns out its return value is 6. And of course, mathematically, 6 does not equal 9. So that's why this is failing. Now, PyTest is not as user-friendly as telling you exactly why the bug is there or how to fix it. This is really just a clue to you what must be wrong. What you're seeing here is a clue that the first test passed because there's no red error below that line of code, but this test failed. Somehow or other, your square function is returning 6 when passed in 3 instead of 9. So at this point, you sort of put your detective hat on, you go back to your actual code, and you think about in calculator.py, how in the world is line 7 of my square function returning 6 instead of 9? And at this point, odds are the light bulb would go off above your head proverbially, and you would see, oh, I'm using addition instead of multiplication. But what PyTest has done for us is automate the process of at least pointing out that error for us. And if I now go in and fix this, let me go ahead and the light bulb has gone off. I changed the plus to a multiply. Now I'm going to go ahead and after clearing my screen, I'm going to run not Python, but PyTest of testcalculator.py. Crossing my fingers again, and now it's green, and I see just a dot, which indicates that my one and only test passed. I'm good. 100% success with my test now after fixing that bug. All right, let me pause here and see if there's any questions.
So my question is, what if a user, instead of, because we are taking input from the user, what if the user is somewhat malicious and types in a string instead of an integer? Or maybe he types in a float or some other data type.
Yeah, so what if the user, like we've seen in past examples, types in cat instead of a number when we're expecting an integer? How do we test for something like that? At the moment, I'm admittedly not testing user input. If I go back to my code here, notice that my calculator function, of course, has the square function that we keep testing and retesting. But notice that all of the user input is currently relegated to my main function. And admittedly, as of now, I am not testing my main function. So there could be one of those bugs. And in fact, there would be, because if the user types in a string like cat instead of an integer like 2 or 3, then line 2, recall, would actually raise a value error exception. So we've seen that before. So when it comes to testing your code, this is actually a good reason for having multiple functions in your program. Rather than putting all of your logic in just the file itself, rather than putting all of the logic in just main, it's actually really good, really helpful practice to break your ideas up into smaller, bite-sized functions that themselves are testable. And what do I mean here? Square is perfectly testable. Why? Because it takes as input a parameter called n, and it returns as output an integer, which is going to be the square thereof, hopefully. It has a well-defined input and a well-defined output. It is therefore completely within your control in your test program to pass in those values. Now, I will say, if you want to test whether square behaves properly when passed something like a string, like quote unquote cat, we could absolutely do something like this. Assert that the square of quote unquote cat, it's not going to equal something. You can actually, using different syntax, assert that a specific exception will be raised. So if we were actually going to go back into our square function, improve it, and deliberately raise an exception, we could test for that too. But for now, I'm deliberately only testing the square function. I'm not testing for specific user input. But that's another problem to be solved. Other questions now on unit tests.
Do you use the unit test to test code for the CS50 check?
So Check50 is similar in spirit. Check50 is a tool that we, CS50, wrote that is essentially doing something like PyTest for the evaluation of students' code. It is similar in spirit, but think of Check50 as being an alternative to PyTest, if you will. But it works a little bit differently. But same idea. PyTest and unit testing more generally is a technique that is independent of CS50 and is something that you can and should be doing on your own code, both in or outside of this class. How about one other question here on our unit tests?
My question is, instead of writing 4 times like assert square of 2 is equal to 4, instead of that, can we write if I is equals to, in square brackets, the numbers we want, instead of writing 4 lines?
A really good question. Absolutely. Right now, if I go back to testcalculator.py, it's indeed pretty manual. I mean, it took me a while to say and to type out those several lines. And you could imagine writing some kind of loop to just assert in a loop that this equals that this equals that, and so forth, using a list or using maybe a list or a dictionary or some structure like that. So yes, you can absolutely automate some of these tests by not just doing the same thing again and again. You can still use all of the syntax of Python to do loops. But generally speaking, your tests should be pretty simple. And in fact, let me propose that we improve upon even this design further, because at the moment, what's not really ideal when I run all of this, when I run all of these tests, when my function is buggy, is notice the output that I got. Let me reintroduce that same bug by changing my multiplication back to addition. Let me increase the size of my terminal window again, and let me run PyTest again of testcalculator.py. So this is the version of my code now that has the bug again. So I'm going to see that big, massive failure where this failure has been displayed to me. But this is not as helpful as it could be, right? Because I have all of those other tests in my code. Recall that I had, what, 1, 2, 3, 4, 5 separate tests, and I'm only seeing the output of the first. Now, why is that? Well, if we go back to my code here, you'll see that the first assertion that's failing, namely this one here, that assert of square of 3 equals 9, the other tests aren't even getting run. And that's not a big deal in the sense that my code is buggy, so one or more of them are probably going to fail anyway. But wouldn't it be nice to know which of them are going to fail? And in fact, it's ideal to run as many tests all at once as possible to give you as many clues as possible to finding your bug. So let me propose that we improve the design of my testing code now, still using PyTest as follows. Instead of having one big function called test square that tests the entire function itself with so many different inputs, let's break down my tests into different categories. And here too, there's no one right way to do this, but my mind is thinking that I should maybe test positive numbers separately, test negative numbers separately, and test 0 separately. I could think of other ways. I could test even numbers, I could test odd numbers, or maybe some other pattern altogether. But separating this big test into multiple tests is probably going to yield more clues for me when something goes wrong. So let me do this. Let me go ahead and rename this function to test positive initially, and let me include in that function only those first 2 tests. Let me then create another function here called test negative, and in this function, let me test only -2 and -3. Then down here, let me do one more def of test 0, and I'll just run one test in there. So I have the same assertions, the same 5, but I've now divided them up among 3 separate functions. What's nice about PyTest and other unit testing frameworks is that all 3 of these test functions will be run automatically. Even if one of them fails, the others will be attempted. That means that if 1 or 2 or 3 of them fail, I'll have 1 or 2 or 3 clues now for helping me find that mistake. So let me go ahead and again increase the size of my terminal window just so we can see more on the screen. My calculator still has the bug using addition instead of multiplication. Let me go ahead and run not Python, but again, PyTest of testcalculator.py, crossing my fingers as always. And now, oh my God, there's even more errors on the screen. But this in itself is more helpful. Let's work through them from top to bottom. So under failures here in all caps, which I know is not very encouraging to see failure when you're just trying to solve a problem, but that's what these frameworks do. Under failures, the first function that failed is test positive. But here too, we see the same clue as before. The first one, 2, the square of 2 equals 4, that one's fine. It's not erring with any red errors, but the next one is failing. So I know that square is broken when I pass in 3. All right, what about down here? It looks like, unfortunately, my test negative function is failing too. Why? Well, when I pass in, oh, this is interesting. Here now, negative 2 doesn't even work. So I got lucky with positive 2, but negative 2 isn't working. So that's a bit of a clue. But in total, only 2 tests failed. So notice at the very bottom, this summary, 2 failed and 1 passed. What's the other one? What was the third one? Test 0. So test 0 is passing. These 2 are failing. And so that kind of leads me logically, mathematically, if you will, to the source of the bug. And just to be clear, too, if you have a lot of tests, this little one-line output is helpful, even though also a bit discouraging. Fail, fail, and dot means pass. So there are the 3 tests just depicted graphically a little bit differently. Well, let me rewind now and go back into calculator.py. Let's fix that bug, because let's suppose that I've deduced, OK, I'm using addition. I should have been using multiplication all this time. Let me now, after fixing the bug yet again, let me go back to my big terminal. Let me run PyTest of testcalculator.py, hitting Enter, crossing my fingers now. And ... means all is well. 100% of my tests passed, all 3 of them. So now I'm good. It doesn't necessarily mean that my code is 100% correct, but it does mean that it has passed 100% of my current tests. And so it would probably behoove us to think a little harder about maybe we should test bigger numbers, maybe we should test even smaller numbers, maybe we should test strings or something else. The onus is ultimately on you to decide what you're going to test. But in the real world, you're going to be very unhappy with yourself or someone else. Maybe your boss is going to be very unhappy with you if you did not catch a bug in your code, which you could have caught had you just written a test to try that kind of input. All right, let me pause again and see if there's any questions now on unit testings with PyTest.
So if you wanted to test, like someone suggested before, user input as well as testing your function, do you do that within the same file, or do you make separate files for different types of tests?
Really good question. You could absolutely make separate files to test different types of things. Or if you don't have that many, you can keep them all in the same file. At the moment, I've been storing all of my tests in one file for convenience, and there's not terribly many of them. But we'll take a look in a bit at an example that allows me to put them into a folder and even run PyTest on a whole folder of tests as well. So that's possible. Other questions on unit testing?
So I've got 2 questions. A couple of while ago, you just used an exception called assertion. I'm not sure what was. Oh yeah, assertion error. What exactly does that particular error catch? And my second question is, does the assert keyword stand out to the compiler and exactly tell them to assert this particular line of code?
Indeed. The assert keyword we're seeing and the assertion error we saw earlier are intertwined. So when you use assert and the assertion fails, because whatever Boolean expression you're using is not true, it's false, an assertion error, by definition of Python, will be raised. So those 2 work in conjunction. Those errors, those assertion errors, are still being raised by my code here when any of these lines of code fail. However, PyTest This third-party library is handling the process of catching those exceptions automatically for me so as to give me this standard output. So we started today's story by really implementing unit testing myself. I wrote all of the code myself. I wrote main. I did my conditional. I did try and except. Honestly, it's going to get incredibly painful to write tests long term if you and I have to write that much code every time, especially when our function is this small. So PyTest and unit testing frameworks like it just automate so much of that. Essentially, PyTest adds the try, the except, the if, the prints for you, so you can just focus on the essence of the tests, which really are these inputs and outputs. How about time for one other question here on unit testing as well?
Sir, when we enter -6 or -5, the square or square root of that number comes up. But when we put 6.6 or 5.6, something like that integer, then line shows error. So what's happening there?
So if I'm deliberately testing integers right now, in large part because I only want POW to operate on integers. And that might be conveyed in Python's documentation or my own documentation for that function. If we were to pass in something else like a float, it turns out that floating point values in Python and other languages are actually very hard, if not impossible, to represent 100% precisely. And so if you are trying to compare it against some other value, they might be slight rounding errors as a result. I'm just inferring from what you've described, but I'm very deliberately now testing this function with only the inputs that I would expect. It might indeed throw other errors if other inputs are passed. All right, allow me to propose that we consider what should happen if square isn't actually passed a number. For instance, if I go back to calculator.py and suppose that I, or perhaps someone else using my square function, simply forgets to convert the return value of input from a str to an int, as by modifying line 2 here. Well, now something's definitely going to go wrong if I type in a str instead of what appears to be an int. For instance, if I clear my terminal here, run Python of calculator.py and hit enter, let's type in cat as our value for x. And of course, this raises now a type error. Why? Can't multiply sequence by non-int of type str. What does that mean? Well, you can't do cat times cat because indeed square is expecting that n will be some number. But that doesn't necessarily mean that square itself is buggy, but this does mean that if I expect a type error to be raised, let's test for that too so that I know the behavior indeed works as expected. So let me go back to testcalculator.py and let me go and add a fourth test down here. How about define test underscore, and I'll call this test str because I'm going to specifically and deliberately pass in a str for testing. And I want to, in spirit, assert that passing in something like cat to square will raise a type error, but we don't use the assert keyword for that. Rather, we need this. Let me go to the top of this file, and let me additionally import the PyTest library itself, because it turns out there's a function in that library called raises that allows me to express that I expect an exception to be raised. And I can express that as follows: with pytest.raises, and then in parentheses, I can pass in the type of exception I expect, which is going to be a type error in this case. And now when do I expect that type error to be raised? Whenever I do something like calling square and passing in not a number, but something like cat. So now if I go back to my terminal window, run pytest of testcalculator.py, this time having 4 tests, I should see that all 4 now are successful. All right, let's now consider how we could test code that doesn't just expect numbers as input, but actually strings. And let me rewind us in time here in VS Code to that very first program we wrote a few different versions of in hello.py that ultimately looked a little something like this. I had a main function that prompted the user for the value of a variable by asking them, what's your name, ? And then we went ahead and did something like hello, open paren name, passing that user's name into a function called hello. Now that function hello, recall, ultimately looked like this. We defined hello as taking a parameter called 2, the default value of which was world, and that function very simply printed hello followed by a comma, and then whatever the name that had been passed in. And then we ultimately called main, but for now onward, I'm going to always add this if conditional, if name equals __ main, then and only then do I want to call main. So that's essentially what this program looked like in its last incarnation. How do we go about testing it? Well, here again, too, I'm not going to test the user's input per se in main. I'm going to focus really on the module of code here that's of interest, which is the hello function itself. How can I go about testing the hello function? Well, unfortunately, even if I start by doing something like code of test hello.py, let me go about and start writing a test program. I could import from my hello program a function called hello. So a bit strange to see from hello import hello, but notice that on this line here, I'm importing from the module, that is the file called hello.py, the function called hello. And how do I go about testing this? Well, if I have a function like define test argument like this, well, let me do this. So if I were to define a function like define test hello, what could I do? Well, I could call hello with quote unquote, say, David, and then check if it equals what? Hello, comma, David? So would this work, this approach here? If I've written a test called test hello that calls hello with an argument of David and then tests its return value, just like we've done for our calculator, would this work as written? And let me go back to, in just a moment, the version of hello that we're testing so you can see that function hello. Here's the test. Here's the actual code. Would this test now work? Any thoughts?
I think the problem is that in the first version in hello.py, you're using the to argument that you first declare when you declare the function instead of using the name.
OK, that is actually not a bug here. So let me stipulate that in hello.py, this code actually does work as intended. And let me go ahead and test it manually just to demonstrate as much. Let me run Python of hello.py, typing in as my name David, and I see, in fact, that it says hello, David. If, though, I were to change this program and get rid of the name argument, get rid of the name variable, and just call hello, again running Python of hello.py. This time, I'm not even prompted because I got rid of my input call, but it does behave as I expect. It does say hello world. So let me stipulate that this code in its current form is actually correct, but my test is not going to work as I'd hoped. And there's a subtle difference between hello versus my pow function that there's a subtle difference between my hello function and my square function that explains. Why might this test not work as intended?
Because it's not returning a value.
Yeah, exactly. Recall our discussion early on about functions. Functions can either return a value, like my square function hands you back the square of some value, or they can have side effects, sort of visual artifacts that might happen on the screen, like printing something out on the screen. And by definition, that's how print works. Notice that hello, it is short, but it's implemented ultimately using the print function, which does not return a value as I'm using it here. It instead has this side effect of printing something onto the screen. So it is not correct in my test function to check if the return value of hello equals hello David, because again, hello is not returning anything. It's printing something with that side effect, but notice literally it has no return keyword, unlike my square function, which did. So here's an opportunity, too, to perhaps change how I go about implementing my actual functions. It turns out that as your programs get more and more sophisticated, more and more complicated, it tends to be best practice not to have side effects if you can avoid it, especially if you want your code to be testable. And in fact, I'm going to propose that we change my hello program to now work as follows. Let me go ahead and change this function to not print hello and then that name. Let me go ahead and literally return maybe an f string, which will clean this up a little bit, hello, comma, 2, close quote at the end. So my syntax here is just the familiar f string or format string. It's going to return hello world or hello David or hello whoever's name is passed in as that argument. But I'm returning it now. I'm not printing it out. So what needs to change up here? Well, I could do something like this. I could say something like output equals hello and then print output in my main function. Or I can simplify that because I don't really need that variable. I could instead just do this. I could still call hello, but I could immediately print out the result. And this version of my hello program now is actually more testable. Why? Because these assert statements that we're using, and we've seen thus far for our tests, are really designed to test arguments into functions and return values therefrom, not testing side effects. So if you're doing equals equals, you're looking for a return value, something that's handed back from the function. So that's fine. If I modify the design of my program now, not to just print hello, but to return the string, the sentence, the phrase that I want to construct, I can leave it to the caller, that is the function who's using this hello function, to handle the actual printing. Now what does this mean in my code? Well, it means now if my hello.py looks like this, and hello is indeed returning a value, in my test hello function, I can test it exactly like this. So let me go ahead and run pytest of test hello.py, crossing my fingers as always, and voila, 1 passed. So I passed this test because apparently the return value of hello does indeed equal hello, comma, David. Well, let's test the other scenario. What if I call hello without any arguments? Let's assert that calling hello with nothing in those parentheses similarly equals hello, comma, but world, the default value. Let me now go ahead and run pytest of test hello.py, and that too passes entirely. But there too, suppose that I had made some mistakes, suppose that there were a bug in my code, it might not be best practice to combine multiple tests in this one function. So let's make it more clear what might pass or fail. Let's call the first function test the default to this function, and let's only include this first line of code. And then let's go ahead and define another function like test argument to test this other line of code here. So now I have 2 different tests, each of which is testing something a little fundamentally different. So now when I run my code, it's still not broken. If I run pytest of test hello.py, enter, I've now passed 2 tests. And that's just as good as before. But if I did have a bug, having 2 tests instead of 1 would indeed give me perhaps a bit more of a hint as to what's wrong. Questions now on this testing of return values when these return values are now strings instead of integers, and why we've done this.
So my question is about function inside the function. Can we test that too? Or recursion we have in C?
If you have a recursive function, which we've not discussed in this class, yes, you can absolutely test those too by simply calling them exactly in this way. Recursion does not affect this process. All right, how about one more question here on unit tests before we look at one final example?
When testing our arguments, like can we use something like loops or inside of assert or for the values?
Absolutely. You can absolutely use a loop to test multiple values. In this case, for instance, I could do something like this. I could say for name in the following list of Hermione, say Harry, and Ron, I could then within this loop assert that hello of that given name equals, say, the format string of hello, comma, name, and then run all of these here at once by running, again, pytest of test hello.py. It's still going to be just one test within that function. But if there's something interesting about those several strings that makes it compelling to test all of them, you can absolutely automate the tests in that way. With that said, each of your tests should ideally be pretty simple and pretty small. Why? Because you don't want to write so much code, so much complicated code that your tests might be flawed. What we don't want to have to do is write tests for our tests and tests for our tests for our tests, because it would never end. So keeping tests nice and simple is really the goal, so that a reasonable human, yourself included, can eyeball them and just claim, yeah, that is correct. We don't need tests for our tests. All right, how about one other feature? Suppose that we don't have just one test, but many different tests instead, and we want to start to organize those tests into multiple files and even a folder. Well, PyTest and other frameworks support that paradigm as well. In fact, let me go ahead and test hello.py using a folder of tests with technically just one test, but it would be representative of having even more in that folder. I'm going to go ahead and create a new folder called tests using makedir at my command line, and then within that file, within that folder, I'm going to go ahead and create a file called testhello.py. Within this file, meanwhile, I'm going to test the same things. I'm going to go ahead and from hello, import hello. And I'm going to go ahead and define a function like test default that simply tests the scenario where hello with no arguments returns hello, comma, world. And I'm going to have that other function where I test that an argument is passed. And in this case, I'll choose an argument like asserting that hello, quote unquote, David, equals indeed hello, comma, Not world, but David. So in this case, I've just recreated the same test as earlier, but they're in a file now in a folder called test. Well, PyTest allows me to run these here too, but to do so, I actually need to create one other file. Within my test directory, I need to create a file called __init__.py, which has the effect, even if this file is empty, of telling Python to treat that folder as not just a module, but a package, so to speak. A package is a Python module or multiple modules that are organized inside of a folder. And this file, __init__py, is just a visual indicator to Python that indeed it should treat that folder as a package. If I had more code in this folder, I could do even more things with this file. But for now, it's just a clue that it's indeed meant to be a package and not just a module or file alone. What I can now do in closing is run PyTest, not even on that specific file, but on a whole folder of tests. So if I run PyTest of test, where the test is the name of that folder, PyTest will automatically search through that folder looking for all possible tests. Granted, there's just those 2 in this one file, but when I run it now with enter, I'll still pass those tests, I'll still get 100%, and I now have a mechanism ultimately for testing my own code. So whether you're writing functions that return integers or something else, functions that have side effects that could be rewritten as functions that return values, you now have a mechanism to not just wait for someone like us to test your code, and not just test your code manually again and again, which might get tedious and you might make mistakes by not including some possible inputs. We now have an automated mechanism for testing one's own code that's going to be even more powerful when you start collaborating with others, so that you can write tests that ensure that if they make a change to the same code, they haven't broken the code that you've written. All right, that's it for this week. We'll see you next time. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on File I/O, input and output of files. So up until now, most every program we've written just stores all the information that it collects in memory, that is, in variables or inside of the program itself, a downside of which is that as soon as the program exits, anything you typed in, anything that you did with that program is lost. Now, with files, of course, on your Mac or PC, you can hang on to information long term. And File I/O within the context of programming is all about writing code that can read from, that is, load information from, or write to, that is, save information to, files themselves. So let's see if we can't transition then from only using memory and variables and the like to actually writing code that saves some files for us and therefore data persistently. Well, to do this, let me propose that we first consider a familiar data structure, a familiar type of variable that we've seen before, that of a list. And using lists, we've been able to store more than one piece of information in the past. Using one variable, we typically store one value. But if that variable is a list, we can store multiple values. Unfortunately, lists are stored in the computer's memory, and so once your program exits, even the contents of those disappear. But let's at least give ourselves a starting point. So I'm over here in VS Code, and I'm going to go ahead and create a simple program using code of names.py, a program that just collects people's names, students' names, if you will. And I'm going to do it super simply initially in a manner consistent with what we've done in the past to get user input and print it back out. I'm going to say something like this. Name equals input, quote unquote, what's your name? Thereby storing in a variable called name the return value of input, as always. And as always, I'm going to go ahead and very simply print out a nice F string that says hello, comma, and then in curly braces name to print out hello David, hello world, however happens to be using the program. Let me go ahead and run this just to remind myself what I should expect. And if I run python of names.py and hit enter, type in my name like David, of course, I now see hello, comma, David. Suppose, though, that we wanted to add support not just for one name, but multiple names, maybe 3 names for the sake of discussion, so that we can begin to accumulate some amount of information in the program such that it's really going to be a downside if we keep throwing it away once the program exits. Well, let me go back into names.py up here at top. Let me proactively give myself a variable, this time called names plural, and set it equal to an empty list. Recall that the square bracket notation, especially if nothing's inside of it, just means give me an empty list that we can add things to over time. Well, what do we want to add to it? Well, let's add 3 names, each from the user. And let me say something like this. For underscore in range of 3, let me go ahead and prompt the user with the input function and getting their name in this variable. And then, using list syntax, I can say names.append name to that list. And now I have in that list that given name, 1, 2, 3 of them. Other points to note is I could use a variable here like I, which is conventional. But if I'm not actually using I explicitly on any subsequent lines, I might as well just use underscore, which is a Pythonic convention. And actually, if I want to clean this up a little bit right now, notice that my name variable doesn't really need to exist because I'm assigning it a value and then immediately appending it. Well, I could tighten this up further by just getting rid of that variable altogether and just appending immediately the return value of input. I think we could go both ways in terms of design here. On the one hand, it's a pretty short line and it's readable. On the other hand, if I were to eventually change this phrase to be not what's your name, but something longer, we might want to break it out again into 2 lines. But for now, I think it's pretty readable. Now, later in the program, let's just go ahead and print out those same names, but let's sort them alphabetically so that it makes sense to be gathering them all together, then sorting them and printing them. So how can I do that? Well, in Python, the simplest way to sort a list in a loop is probably to do something like this. For name in names, but wait, let's sort the names first. Recall that there's a function called sorted, which will return a sorted version of that list. Now let's go ahead and print out an f string that says, again, hello, bracket name, close quotes. All right, let me go ahead and run this. So Python of names.py. And let me go ahead and type in a few names this time. How about Hermione? How about Harry? How about Ron? And notice that they're not quite in alphabetical order, but when I hit enter and that loop kicks in, it's going to print out hello Harry, hello Hermione, hello Ron in sorted order. But of course now, if I run this program again, all of the names are lost. And if this is a bigger program than this, that might actually be pretty painful to have to re-input the same information again and again and again. Wouldn't it be nice, like most any program today on a phone or a laptop or desktop or cloud, to be able to save this information somehow instead? And that's where file I/O comes in, and that's where files come in. They are a way of storing information persistently on your own phone or Mac or PC or some cloud server's disk so that they're there when you come back and run the program again. So how can we go about saving all 3 of these names in a file as opposed to having to type them again and again? Let me go ahead and simplify this file and again give myself just a single variable called name and set the return value of input equal to that variable. So what's your name as before, quote unquote. And now let me go ahead and let me do something more with this value. Instead of just adding it to a list or printing it immediately out, let's save the value of the person's name that's just been typed in to a file. Well, how do we go about doing that? Well, in Python, there's this function called open, whose purpose in life is to do just that, to open a file. But to open it up programmatically so that you, the programmer, can actually read information from it or write information to it. So open is like the programmer's equivalent of like double-clicking on an icon on your Mac or PC. But it's a programmer's technique because it's going to allow you to specify exactly what you want to read from or write to that file. Formally, its documentation is here, and you'll see that its usage is relatively straightforward. It minimally just requires the name of the file that we want to open and optionally how we want to open it. So let me go back to VS Code here, and let me propose now that I do this. I'm going to go ahead and call this function called open, passing in an argument for names.txt, which is the name of the file I would like to store all of these names in. I could call it anything I want, but because it's going to be just text, it's conventional to call it something.txt. But I'm also going to tell the open function that I plan to write to this file. So as a second argument to open, I'm going to put literally quote unquote W for write, and that's going to tell open to open the file in a way that's going to allow me to change the contents. And better yet, if it doesn't even exist yet, it's going to create the file for me. Now, open returns what's called a file handle, a special value that allows me to access that file subsequently. So I'm going to go ahead and assign it equal to a variable like file. And now I'm going to go ahead and quite simply write this person's name to that file. So I'm going to literally type file, which is the variable linking to that file, .write, which is a function, otherwise known as a method that comes with open files that allows me to write that name to the file. And then lastly, I'm going to quite simply go ahead and say file.close, which will close and effectively save the file. So these 3 lines of code here are essentially the programmer's equivalent to like double-clicking an icon on your Mac or PC, making some changes in Microsoft Word or some other program, and going to File, Save. We're doing that all in code with just these 3 lines here. Well, let's see now how this works. Let me go ahead now and run Python of names.py and enter. Let's type in a name. I'll type in Hermione. Enter. All right. Where did she end up? Well, let me go ahead now and type code of names.txt, which is a file that happens now to exist because I opened it in write mode. And if I open this in a tab, we'll see there's Hermione. Well, let's go ahead and run names.py once more. I'm going to go ahead and run Python of names.py, enter, and this time I'll type in Harry. Let me go ahead and run it one more time, and this time I'll type in Ron. And now let me go up to names.txt, where hopefully I'll see all 3 of them here. But no, I've just actually seen Ron. What might explain what happened to Hermione and Harry, even though I'm pretty sure I ran the program 3 times, and I definitely wrote the code that writes their name to that file. What's going on here, do you think?
I think because we are not appending them, we should append the names. Since we are writing directly, it is erasing the old content and it is replacing with the last set of characters that we mentioned.
Exactly. Unfortunately, quote unquote W is a little dangerous. Not only will it create the file for you, it will also recreate the file for you every time you open the file in that mode. So if you open the file once and write Hermione, that worked just fine as we saw. But if you do it again for Harry, if you do it again for Ron, the code is working, but each time it's opening the file and recreating it with brand new contents. So we had one version with Hermione, one version with Harry, and one final version with Ron. But ideally, I think we probably want to be appending, as Vishal says, each of those names to the file, not just clobbering, that is overwriting the file each time. So how can I do this? It's actually a relatively easy fix. Let me go ahead and do this as follows. I'm going to first remove the old version of names.txt, and now I'm going to change my code to do this. I'm going to change the W, quote unquote, to just A, quote unquote, A for append, which means to add to the bottom, to the bottom, to the bottom, again and again. Now let me go ahead and rerun Python of names.py, enter. I'll again start from scratch with Hermione, because I'm creating the file new. Notice that if I now do code of names.txt, enter, we do see that Hermione is back. So after removing the file, it did get recreated, even though I'm using append, which is good. But now let's see what happens when I go back to my terminal. And this time I run Python of names.py again, this time typing in Harry. And let me run it one more time, this time typing in Ron. So hopefully this time, in that second tab, names.txt, I should now see all 3 of them. But, this doesn't look ideal. What have I clearly done wrong? Something tells me, even though all 3 names are there, it's not going to be easy to read those back unless you know where each name ends and begins.
The English format is not correct. It's incorrect. It's concatenating them.
It is. Well, it appears to be concatenating, but technically speaking, it's just appending to the file. First Hermione, then Harry, then Ron. It has the effect of combining them back to back, but it's not concatenating per se. It really is just appending. Let's go to another hand here. What really have I done wrong? Or equivalently, how might I fix? It would be nice if there were some kind of gaps between each of the names so we could read them more cleanly.
Hello, we should add a new line before we write new name.
Good. We want to add a new line ourselves. So whereas print by default, recall, always outputs automatically a line ending of \n unless we override it with the named parameter called end, Write does not do that. Write takes you literally. And if you say write Hermione, that's it. You're getting the H through the E. If you say write Harry, you get the H through the Y. You don't get any extra new lines automatically. So if you want to have a new line at the end of each of these names, we've got to do that manually. So let me again close names.txt, and let me remove the current file. And let me go back up to my code here. And I can fix this in any number of ways, but I'm just going to go ahead and do this. I'm going to write out an F string that contains name and \n at the end. We could do this in different ways. We could manually print just the new line or some other technique. But I'm going to go ahead and use my F strings, as I'm in the habit of doing, and just print the name and the new line all at once. I'm going to go ahead now and down to my terminal window, run python of names.py again, enter. We'll type in Hermione. I'm going to run it again, type in Harry. I'm going to type it again, and this time Ron. Now I'm going to run code of names.txt and open that file. And now it looks like the file is a bit cleaner. Indeed, I have each of the name on its own line, as well as a line ending, which ensures that we can separate one from the other. Now, if I were writing code, I bet I could parse, that is, read the previous file by looking at differences between lowercase and uppercase letters, but that's going to get messy quickly. Generally speaking, when storing data long term in a file, you should probably do it somehow cleanly, like doing one name at a time. Well, let's now go back, and I'll propose that this code is now working correctly, but we can design it a little bit better. It turns out that it's all too easy when writing code to sometimes forget to close files. And sometimes this isn't necessarily a big deal, but sometimes it can create problems. Files could get corrupted or accidentally deleted or the like, depending on what happens in your code. So it turns out that you don't strictly need to call close on the file yourself if you take another approach instead. More Pythonic when manipulating files is to do this, to introduce this other keyword called, quite simply, with, that allows you to specify that in this context, I want you to open and automatically close some file. So how do we use with? It simply looks like this. Let me go back to my code here. I've gotten rid of the close line, and I'm now just going to say this instead. Instead of saying file equals open, I'm going to say with open, then the same arguments as before, and somewhat curiously, I'm going to put the variable at the end of the line. Why? That's just the way this is done. You say with, you call the function in question, and then you say as, and specify the name of the variable that should be assigned the return value of open. Then I'm going to go ahead and indent the line underneath so that the line of code that's writing the name is now in the context of this with statement, which just ensures that automatically, if I had more code in this file down below, no longer indented, the file would be automatically closed as soon as line 4 is done executing. So it doesn't change what has just happened, but it does automate the process of at least closing things for us, just to ensure I don't forget and so that something doesn't go wrong. But suppose now that I wanted to read these names from the file. All I've done thus far is write code that writes names to the file. But let's assume now that we have all of these names in the file. And heck, let's go ahead and add one more. Let me go ahead and run this one more time, python of names.py. And let's add in Draco to the mix. So now that we have all 4 of these names here, how might we want to read them back? Well, let me propose that we go into names.py now, or we could create another program altogether, but I'm going to keep reusing the same name just to keep us focused on this. And now I'm going to write code that reads an existing file with Hermione, Harry, Ron, and Draco together. And how do I do this? Well, it's similar in spirit. I'm going to start this time with open. And then the first argument is going to be the name of the file that I want to open, as before. And I'm going to go open it this time in read mode, quote unquote R. And to read a file just means to load it, not to save it. And I'm going to name the return value file. And now I'm going to do this. And there's a number of ways I can do this. But one way to read all of the lines from the file at once would be this. Let me declare a variable called lines. Let me access that file and call a function or a method that comes with it called readLines. So if you read the documentation on file IO in Python, you'll see that open files come with a special method whose purpose in life is to read all of the lines from the file and return them to me as a list. So what this line 2 is doing is it's reading all of the lines from that file, storing them in a variable called lines. Now suppose I want to iterate over all of those lines and print out each of those names. For line in lines, this is just a standard for loop in Python. Lines is a list. Line is the variable that will be automatically be set to each of those lines. Let me go ahead and print out something like, oh, hello, comma, and then I'll print out the line itself. All right, so let me go to my terminal window, run Python of names.py now. I have not deleted names.txt, so it still contains all 4 of those names, and hit enter. And OK, it's not bad, but it's a little ugly here. What's going on? When I ran names.py, it's saying hello to Hermione, to Harry, to Ron, to Draco, but there's these gaps now between the lines. What explains that symptom? If nothing else, it just looks ugly.
It happens because in the text file, we have new line symbols in between those names, and the print always adds another new line at the end. So you use the same symbol twice.
Perfect. And here's a good example of a bug, a mistake in a program. But if you just think about those first principles, like how do each of the lines of code work that I'm using, you should be able to reason exactly as Rafal did there to say that, all right, well, one of those new lines is coming from the file after each name. And then, of course, print all of these weeks later is still giving us for free that extra new line. So there's a couple possible solutions. I could certainly do this, which we've done in the past, and pass in a named argument to print, like end equals quote unquote. And that's fine. I would argue a little better than that might actually be to do this, to strip off of the end of the line the actual new line itself, so that print is handling the printing of everything, the person's name as well as the new line. But you're just stripping off what is really just an implementation detail in the file. We chose to use new lines in my text file to separate one name from another. So arguably, it should be a little cleaner in terms of design to strip that off and then let print out what is really just now a name. But that's ultimately a design decision. The effect is going to be exactly the same. Well, if I'm going to open this file and read all the lines and then iterate over all of those lines and print them each out, I could actually combine this into one thing. Because right now, I'm doing twice as much work. I'm reading all of the lines, then I'm iterating over all of the lines just to print out each of them. Well, in Python with files, you can actually do this. I'm going to erase almost all of these lines now, keeping only the with statement at top. And inside of this with statement, I'm going to say this. For line in file, go ahead and print out, quote unquote, hello, comma, and then line.rstrip. So I'm going to take the approach of stripping off the end of the line. But notice how elegant this is, so to speak. I've opened the file in line 1. And if I want to iterate over every line in the file, I don't have to very explicitly read all the lines, then iterate over all of the lines. I can combine this into one thought. In Python, you can simply say for line in file. And that's going to have the effect of giving you a for loop that iterates over every line in the file one at a time. And on each iteration, updating the value of this variable line to be Hermione, then Harry, then Ron, then Draco. So this, again, is one of the appealing aspects of Python, is that it reads rather like English. For line in file, print this. It's a little more compact when written this way. Well, what if, though, I don't want quite this behavior? Because notice now, if I run Python of names.py, it's correct. I'm seeing each of the names and each of the hellos, and there's no extra spaces in between. But just to be difficult, I'd really like us to be sorting these hellos. Really, I'd like to see Draco first, then Harry, then Hermione, then Ron, no matter what order they appear in the file. So I could go in, of course, to the file and manually change the file. But if that file is changing over time based on who is typing their name into the program, that's not really a good solution. In code, I should be able to load the file no matter what it looks like and just sort it all at once. Now, here is a reason to not do what I've just done. I can't iterate over each line in the file and print it out, but sort everything in advance, right? Logically, if I'm looking at each line one at a time and printing it out, it's too late to sort. I really need to read all of the lines first without printing them, sort them, then print them. So we have to take a step back in order to add now this new feature. So how can I do this? Well, let me combine some ideas from before. Let me go ahead and start fresh with this. Let me give myself a list called names and assign it an empty list, just so I have a variable in which to accumulate all of these lines. And now let me open the file with open, quote unquote, names.txt. And it turns out, I can tighten this up a little bit. It turns out if you're opening a file to read it, you don't need to specify quote unquote R. That is the implicit default. So you can tighten things up by just saying open names.txt, and you'll be able to read the file, but not write it. I'm going to give myself a variable called file, as before. I am going to iterate over the file in the same way for line in file, but instead of printing each line, I'm going to do this. I'm going to take my names list and append to it, and this is appending to a list in memory, not appending to the file itself, I'm going to go ahead and append the current line, but I'm going to strip off the new line at the end so that all I'm adding to this list is each of the students' names. Now I can use that familiar technique from before. Let me go outside of this with statement, because now I've read the entire file, presumably. So by the time I'm done with lines 4 and 5, again and again and again for each line in the file, I'm done with the file. It can close. I now have all of the students' names in this list variable. Let me do this. For name in, not just names, but the sorted names, using our Python function sorted, which does just that, and do print, quote unquote, with an F string, hello, comma, and now I'll plug in bracket name. So now what have I done? I'm creating a list at the beginning just so I have a place to gather my data. I then, on lines 3 through 5, iterate over the file from top to bottom, reading in each line one at a time, stripping off the new line and adding just the student's name to this list. And the reason I'm doing that is so that on line 7, I can sort all of those names now that they're all in memory and print them in order. I need to load them all into memory before I can sort them. Otherwise, I'd be printing them out prematurely, and Draco would end up last instead of first. So let me go ahead in my terminal window and run Python of names.py now and hit Enter. And there we go. The same list of 4 hellos, but now they're sorted. And this is a very common technique when dealing with files and information more generally. If you want to change that data in some way, like sorting it, creating some kind of variable at the top of your program like a list, adding or appending information to it just to collect it in one place, and then do something interesting with that collection, that list, is exactly what I've done here. Now, I should note that if we just want to sort the file, we can actually do this even more simply in Python, particularly by not bothering with this names list, nor the second for loop. And let me go ahead and instead just do more simply this. Let me go ahead and tell Python that we want the file itself to be sorted using that same sorted function, but this time on the file itself. And then inside of that for loop, let's just go ahead and print right away our hello, comma, followed by the line itself, but still stripping off of the end of it any white space therein. If we go ahead and run this same program now with Python of names.py and hit Enter, we get the same result, but of course it's a lot more compact. But for the sake of discussion, let's assume that we do actually want to potentially make some changes to the data as we iterate over it. So let me undo those changes, leave things as is, whereby now we'll continue to accumulate all of the names first into a list, maybe do something to them, maybe forcing them to uppercase or lowercase or the like, and then sort and print out each item. Let me pause and see if there's any questions now on file I/O, reading or writing, or now accumulating all of these values in some list.
Hi, is there a way to sort the files, but instead if you want it from alphabetically from A to Z, is there a way to reverse it from Z to A? Is there like a little extension that you can add to the end to do that, or would you have to create a new function?
If you wanted to reverse the contents of the file?
Yeah, so if you, instead of sorting them from A to Z in ascending order, if you wanted them in descending order, is there an extension for that?
There is indeed. And as always, the documentation is your friend. So if the goal is to sort them, not in alphabetical order, which is the default, but maybe reverse alphabetical order, you can take a look, for instance, at the formal Python documentation there. And what you'll see is this summary. You'll see that the sorted function takes a first argument, generally known as an iterable. And something that's iterable means that you can iterate over it. That is, you can loop over it, one thing at a time. What the rest of this line here means is that you can specify a key, like how you want to sort it, but more on that later. But this last named parameter here is reverse. And by default, per the documentation, it's false. It will not be reversed by default. But if we change that to true, I bet we can do that. So let me go back to VS Code here and do just that. Let me go ahead and pass in a second argument to sorted in addition to this iterable, which is my names list. Iterable again in the sense that it can be looped over. And let me pass in reverse equals true, thereby overriding the default of false. Let me now run Python of names.py, and now Ron's at the top and Draco's at the bottom. So there too, whenever you have a question like that moving forward, consider what does the documentation say and see if there's a germ of an idea there, because odds are if you have some problem, odds are some programmer before you has had the same question. Other thoughts?
Can we limit numbers of names? And the second question, can we find specific name in list?
Really good question. Can we limit the number of the names in the file, and can we find a specific one? We absolutely could. If we were to write code, we could, for instance, open the file first, count how many lines are already there, and then if there's too many already, we could just exit with sys.exit or some other message to indicate to the user that, sorry, the class is full. As for finding someone specifically, absolutely. You could imagine opening the file, iterating over it with a for loop again and again, and then adding a conditional. Like if the current line equals Harry, then we found the chosen run. And you can print something like that. So you can absolutely combine these ideas with previous ideas like conditionals to ask those same questions. How about one other question on file I/O?
So I just thought about this function like read all lines, and it looks like it's like separate all the lines by this special character \n, but it looks like we don't need it character, and we always strip it, and it looks like some bad design of function. Why wouldn't we just strip it inside this function?
A really good question. So we are, in my examples thus far, using rstrip to reverse, strip from the end of the line all of this white space. You might not want to do that. In this case, I am stripping it away because I know that each of those lines isn't some generic line of text. Each line really represents a name that I have put there myself. I'm using the new line just to separate one value from another. In other scenarios, you might very well want to keep that line ending because it's a very long series of text or a paragraph or something like that where you want to keep it distinct from the others. But it's just a convention. We have to use something, presumably, to separate one chunk of text from another. There are other functions in Python that will, in fact, handle the removal of that white space for you. Readlines, though, does literally that, though. It reads all of the lines as is. Well, allow me to turn our attention back to where we left off here, which is just names, to propose that with names.txt, we have an ability, it seems, to store each of these names pretty straightforwardly. But what if we wanted to keep track of other information as well? Suppose that we wanted to store information including a student's name and their house at Hogwarts, be it Gryffindor or Slytherin or something else. Well, where do we go about putting that? You know, Hermione lives in Gryffindor, so we could do something like this in our text file. Harry lives in Gryffindor, so we could do that. Ron lives in Gryffindor, so we could do that. And Draco lives in Slytherin, so we could do that. But I worry here. But I worry now that we're mixing apples and oranges, so to speak. Like some lines are names, some lines are houses. So this probably isn't the best design, if only because it's confusing or it's ambiguous. So maybe what we could do is adopt a convention. And indeed, this is in fact what a lot of programmers do. They change this file not to be names.txt, but instead let me create a new file called names.csv. CSV stands for comma separated values, and it's a very common convention to store multiple pieces of information that are related in the same file. And so to do this, I'm going to separate each of these types of data not with another new line, but simply with a comma. I'm going to keep each student on their own line, but I'm going to separate the information about each student using a comma instead. And so now we sort of have a two-dimensional file, if you will. Row by row, we have our students. But if you think of these commas as representing a column, even though it's not perfectly straight because of the lengths of these names, it's a little jagged, you can think of these commas as representing a column. And it turns out these CSV files are very commonly used when you use something like Microsoft Excel, Apple Numbers, or Google Spreadsheets, and you want to export the data to share with someone else as a CSV file. Or conversely, if you want to import a CSV file into your preferred spreadsheet software like Excel or Numbers or Google Spreadsheets, you can do that as well. So CSV is a very common, very simple text format that just separates values with commas and different types of values ultimately with new lines as well. Let me go ahead and run code of students.csv to create a brand new file that's initially empty, and we'll add to it those same names, but also some other information as well. So if I now have this new file, students.csv, inside of which is one column of names, so to speak, and one column of houses, how do I go about changing my code to read not just those names, but also those names and houses so that they're not all on one line? We somehow have access to both type of value separately. Well, let me go ahead and create a new program here called students.py. And in this program, let's go about reading not a text file per se, but a specific type of text file, a CSV, a comma separated values file. And to do this, I'm going to use similar code as before. I'm going to say with open quote unquote students.csv. I'm not going to bother specifying quote unquote r, because again, that's the default, but I'm going to give myself a variable name of file. And then in this file, I'm going to go ahead and do this. For line in file as before. And now I have to be a bit clever here. Let me go back to students.csv, looking at this file, and it seems that on my loop, on each iteration, I'm going to get access to the whole line of text. I'm not going to automatically get access to just Hermione or just Gryffindor. Recall that the loop is going to give me each full line of text. So logically, what would you propose that we do inside of a for loop that's reading a whole line of text at once, but we now want to get access to the individual values, like Hermione and Gryffindor, Harry and Gryffindor? How do we go about taking one line of text and gaining access to those individual values, do you think? Just instinctively, even if you're not sure what the name of the functions would be.
You can access it as you would as if you were using a dictionary, like using a key and value.
So ideally, we would access it using a key and value. But at this point in the story, all we have is this loop. And this loop is giving me one line of text at a time. I'm the programmer now. I have to solve this. There is no dictionary yet in question. How about another suggestion here?
So you can somehow split the two words based on the comma.
Yeah, even if you're not quite sure what function is going to do this, intuitively you want to take this whole line of text, Hermione, comma, Gryffindor, Harry, comma, Gryffindor, and so forth, and split that line into two pieces, if you will. And it turns out wonderfully, the function we'll use is actually called split, that can split on any characters, but you can tell it what character to use. So I'm going to go back into students.py, and inside of this loop, I'm going to go ahead and do this. I'm going to take the current line. I'm going to remove the white space at the end, as always, using rstrip here. And then whatever the result of that is, I'm going to now call split and quote unquote comma. So the split function or method comes with strings, strs in Python. Any stir has this method built in. And if you pass in an argument like a comma, what this split function will do is split that current string into 1, 2, 3, maybe more pieces by looking for that character again and again. Ultimately, split is going to return to us a list of all of the individual parts to the left and to the right of those commas. So I can give myself a variable called row here. And this is a common paradigm. When you know you're iterating over a file, specifically a CSV, it's common to think of each line of it as being a row. And each of the values therein separated by commas as columns, so to speak. So I'm going to deliberately name my variable row just to be consistent with that convention. And now what do I want to print? Well, I'm going to go ahead and say this. Print, how about the following? An F string that starts with curly braces. Well, how do I get access to the first thing in that row? Well, the row is going to have how many parts? 2. Because if I'm splitting on commas, and there's 1 comma per line, that's going to give me a left part and a right part, like Hermione and Gryffindor, Harry and Gryffindor. When I have a list like row, how do I get access to individual values? Well, I can do this. I can say row bracket 0. And that's going to go to the first element of the list, which should hopefully be the student's name. Then after that, I'm going to say is in, and I'm going to have another curly brace here for row bracket 1. And then I'm going to close my whole quote. So it looks a little cryptic at first glance, but most of this is just F-string syntax with curly braces to plug in values. And what values am I plugging in? Well, row, again, is a list, and it has 2 elements, presumably. Hermione in one and Gryffindor in the other, and so forth. So bracket 0 is the first element, because remember, we start indexing at 0 in Python, and 1 is going to be the second element. So let me go ahead and run this now and see what happens. Python of students.py, enter, and we see Hermione's in Gryffindor, Harry's in Gryffindor, Ron is in Gryffindor, and Draco is in Slytherin. So we have now implemented our own code from scratch that actually parses, that is, reads and interprets a CSV file ultimately here. Now let me pause to see if there's any questions, but we'll make this even easier to read in just a moment. Any questions on what we've just done here by splitting by comma?
So my question is, can we edit any line of code anytime we want, or the only option that we have is to append the lines. Or let's say if we want to, let's say, change Harry's house to, let's say, Slytherin or some other house.
Yeah, a really good question. What if you want to, in Python, change a line in the file and not just append to the end? You would have to implement that logic yourself. So for instance, you could imagine now opening the file and reading all of the contents in, then maybe iterating over each of those lines. And as soon as you see that the current name equals Harry, you could maybe change his house to Slytherin. And then it would be up to you, though, to write all of those changes back to the file. So in that case, you might want to, in simplest form, read the file once and let it close, then open it again, but open for writing and change the whole file. It's not really possible or easy to go in and change just part of the file, though you can do it. It's easier to actually read the whole file, make your changes in memory, then write the whole file out. But for larger files where that might be quite slow, you can be more clever than that. Well, let me propose now that we clean this up a little bit, because I actually think this is a little cryptic to read, row bracket 0, row bracket 1. It's not that well written at the moment, I would say. But it turns out that when you have a variable that's a list, like row, you don't have to throw all of those variables into a list. You can actually unpack that whole sequence at once. That is to say, if you know that a function like split returns a list, but you know in advance that it's going to return two values in a list, the first and the second, you don't have to throw them all into a variable that itself is a list. You can actually unpack them simultaneously into two variables, doing name, comma, house. So this is a nice Python technique to not only create but assign automatically in parallel two variables at once, rather than just one. So this will have the effect of putting the name in the left, Hermione, and it will have the effect of putting Gryffindor, the house, in the right variable. And we now no longer have a row. We can now make our code a little more readable by now literally just saying name down here and, for instance, house down here. So just a little more readable, even though functionally the code now is exactly the same. All right, so this now works, and I'll confirm as much by just running it once more. Python of students.py, enter, and we see that the text is as intended. But suppose for the sake of discussion that I'd like to sort this list of output. I'd like to say hello again to Draco first, then hello to Harry, then Hermione, then Ron. How can I go about doing this? Well, let's take some inspiration from the previous example where we were only dealing with names, and instead do it with these full phrases. So-and-so is in house. Well, let me go ahead and do this. I'm going to go ahead and start scratch and give myself a list called students, equal to an empty list initially. And then with open students.csv as file, I'm going to go ahead and say this. For line in file. And then below this, I'm going to do exactly as before. Name, comma, house equals the current line, stripping off the white space at the end, splitting it on a comma. So that's exact same as before. But this time, before I go about printing the sentence, I'm going to store it temporarily in a list so that I can accumulate all of these sentences and then sort them later. So let me go ahead and do this. Students, which is my list, dot append. Let me append the actual sentence I want to show on the screen. So another F string. So name is in house, just as before. But notice I'm not printing that sentence. I'm appending it to my list. Not a file, but to my list. Why am I doing this? Well, just because, as before, I want to do this. For student in the sorted students, I want to go ahead and print out student, like this. Well, let me go ahead and run Python of students.py and hit enter now, and I think we'll see, indeed, Draco is now first, Harry is second, Hermione is third, and Ron is fourth. But this is arguably a little sloppy, right? It seems a little hackish that I'm constructing these sentences, and even though I'm technically want to sort by name, I'm technically sorting by these whole English sentences. So it's not wrong, it's achieving the intended result, but it's not really well designed because I'm just kind of getting lucky that English is reading from left to right, and therefore when I print this out, it's sorting properly. It would be better really to come up with a technique for sorting by the students' names, not by some English sentence that I've constructed here on line 6. So to achieve this, I'm going to need to make my life more complicated for a moment, and I'm going to need to collect information about each student before I bother assembling that sentence. So let me propose that we do this. Let me go ahead and undo these last few lines of code so that we currently have two variables, name and house, each of which has name and the student's house respectively, and we still have our global variable students. But let me do this. Recall that Python supports dictionaries, and dictionaries are just collections of keys and values. So you can associate something with something else, like a name with Hermione, like a house with Gryffindor. That really is a dictionary. So let me do this. Let me temporarily create a dictionary that stores this association of name with house. Let me go ahead and do this. Let me say that the student here is going to be represented initially by an empty dictionary. And just like you can create an empty list with square brackets, you can create an empty dictionary with curly braces. So give me an empty dictionary that will soon have two keys, name and house. How do I do that? Well, I could do it this way. Student, open bracket, name, equals the student's name that we got from the line. Student bracket house equals the house that we got from the line. And now I'm going to append to the students list, plural, that particular student. Now, why have I done this? I've admittedly made my code more complicated. It's more lines of code. But I've now collected all of the information I have about students while still keeping track. What's a name? What's a house? The list, meanwhile, has all of the students' names and houses together. Now, why have I done this? Well, let me, for the moment, just do something simple. Let me do for student in students, and let me very simply now say print the following f string. The current student with this name is in this current student's house. And now notice one detail. Inside of this f string, I'm using my curly braces as always. I'm using inside of those curly braces the name of a variable as always. But then I'm using not bracket 0 or 1, because these are dictionaries now, not list. But why am I using single quotes to surround house and to surround name? Why single quotes inside of this f string to access those keys?
Yes, because you have double quotes in that line 12, and so you have to tell Python to differentiate.
Exactly, because I'm already using double quotes outside of the f string. If I want to put quotes around any strings on the inside, which I do need to do for dictionaries, because recall, when you index into a dictionary, you don't use numbers like lists, 0, 1, 2, onward. You instead use strings, which need to be quoted. But if you're already using double quotes, it's easiest to then use single quotes on the inside so Python doesn't get confused about what lines up with what. So at the moment, when I run this program, it's going to print out those hellos, but they're not yet sorted. In fact, what I now have is a list of dictionaries. Nothing is yet sorted, but let me tighten up the code too to point out that it doesn't need to be quite as verbose. If you're in the habit of creating an empty dictionary, like this on line 6, and then immediately putting in two keys, name and house, each with two values, name and house respectively, you can actually do this all at once. So let me show you a slightly different syntax. I can do this. Give me a variable called student, and let me use curly braces on the right-hand side here. But instead of leaving them empty, let's just define those keys and those values now. Quote unquote name will be name, and quote unquote house will be house. This achieves the exact same effect in one line instead of 3. It creates a new non-empty dictionary containing a name key, the value of which is the student's name, and a house key, the value of which is the student's house. Nothing else needs to change. That will still just work, so that if I again run Python of students.py, I'm still seeing those greetings, but they're still not quite actually sorted. Well, what might I go about doing here in order to, what could I do to improve upon this further? Well, we need some mechanism now of sorting those students. But unfortunately, you can't do this. We can't sort all of the students now because those students are not names like they were before. They aren't sentences like they were before. Each of the students is a dictionary, and it's non-obvious how you would sort a dictionary inside of a list. So ideally, what do we want to do? If at the moment we hit line 9, we have a list of all of these students, and inside of that list is one dictionary per student, And each of those dictionaries has two keys, name and house. Wouldn't it be nice if there were a way in code to tell Python, sort this list by looking at this key in each dictionary? Because that would give us the ability to sort either by name or even by house or even by any other field that we add to that file. So it turns out we can do this. We can tell the sorted function not just to reverse things or not. It takes another named parameter called key, where you can specify what key should be used in order to sort some list of dictionaries. And I'm going to propose that we do this. I'm going to first define a function temporarily for now called getName. And this function's purpose in life, given a student, is to quite simply return the student's name from that particular dictionary. So if student is a dictionary, this is going to return literally the student's name. And that's it. That's the sole purpose of this function in life. What do I now want to do? Well, now that I have a function that, given a student, will return to me the student's name, I can do this. I can change sorted to say, use a key that's equal to whatever the return value of getName is. And this now is a feature of Python. Python allows you to pass functions as arguments in two other functions. So getName is a function. Sorted is a function, and I'm passing in getName to sorted as the value of that key parameter. Now, why am I doing that? Well, if you think of the getName function as just a block of code that will get the name of a student, that's handy because that's the capability that sorted needs. When given a list of students, each of which is a dictionary, sorted needs to know, how do I get the name of the student in order to do alphabetical sorting for you? The authors of Python didn't know that we were going to be creating students here in this class, so they couldn't have anticipated writing code in advance that specifically sorts on a field called student, let alone called name, let alone house. So what did they do? They instead built into the sorted function this named parameter key that allows us all these years later to tell their function sorted how to sort this list of dictionaries. So now watch what happens. If I run Python of students.py and hit enter, I now have a sorted list of output. Why? Because now that list of dictionaries has all been sorted by the student's name. I can further do this. If, as before, we want to reverse the whole thing by saying reverse equals true, we can do that too. Let me rerun Python of students.py and hit enter. Now it's reversed. Now it's Ron, then Hermione, Harry, and Draco. But we can do something different as well. What if I want to sort, for instance, by house name reversed? I could do this. I could change